Have you ever thought that a tiny object small enough to fit in your palm is silently consuming more than a third of your life? Not gold, jewelry, or luxury goods, but the iPhone you're holding between your fingers right now. Behind its simple exterior lies an unimaginably complex manufacturing adventure. From the bauxite mines where the aluminum skeleton is made to the space technology standard clean rooms where screens are manufactured, each iPhone goes through hundreds of meticulous and complex steps before reaching your fingertips. In today's video, we'll examine the complete manufacturing cycle of the iPhone from start to finish. You're invited to discover the hidden world of the iPhone you use in your daily life and understand why this level of precision is admired worldwide. When it comes to smart devices, one brand inevitably stands out: Apple. Since its launch in 2007, the iPhone has not only redefined the smartphone industry, but has also created enormous economic value. Today, the iPhone represents more than half of Apple's total revenue and holds the position of the world's most profitable consumer product. Before reaching your palms, each iPhone must pass through more than 800 rigorous inspections. Any device that falls short at any step is immediately eliminated from the production chain as if it never existed. The iPhone is not just a cell phone, it's a symbol that has been the subject of global debate for over a decade. Some call it overpriced, some find it imaginary, but no one can deny that this tiny device reflects prestige, design perception, and even its user's lifestyle. The excavation process begins at the bauxite mine. To break apart solid mineral layers, experts apply controlled drilling and blasting, liberating the bauxite from within the main formation. Giant scoops and transport vehicles work continuously to transport the ore from surface layers to the collection center. After mining, the ore is transferred via long conveyor belts to high-capacity crushing systems, where it's separated from impurities and classified. Each bauxite particle is thoroughly cleaned, purified, and prepared for the next step in the aluminum manufacturing journey. Here, temperature, chemicals, and electrical power will transform the raw mineral into pure metal, to be reborn as the aluminum body of modern iPhones. After leaving the mine, bauxite reaches the processing center where high temperatures and intense pressures awaken the metallic potential from the depths of the earth. The ore dissolves in a caustic mixture, leaving alumina, a snow-white powder. But this is just the beginning. Alumina is melted in enormous electric currents of thousands of amperes, separating the oxygen and producing pure aluminum, a lightweight, bright, and durable element. From the initial droplets of molten aluminum, perfectly alloyed plates are manufactured, ready to advance to the iPhone body shaping phase. When molten aluminum evolves into initial alloy plates, it becomes suitable for entering the iPhone frame shaping operation. Here, high-speed milling devices carve each tiny point with a precision of 1/1000th of a millimeter, manufacturing iPhone skeletons with exact accuracy. As milling cutters carve and shape aluminum skeletons, an enormous amount of heat is generated, which can damage the raw material or dull the cutting tools. For this reason, water or specially formulated cooling liquids are continuously sprayed throughout the entire process to maintain balance and precision. Once the skeleton is mechanically shaped, the process shifts to a completely different plane, the universe of ultra-pure raw materials and nanoscience. After chip design is finalized, the manufacturing of the processor, the brain of the device, officially begins. Absolute precision is vital at this stage. A single dust particle or a few micrometers of deviation is sufficient to render the entire part unusable. In top-level clean rooms, lithography devices worth hundreds of millions of dollars use ultraviolet radiation to etch ultra-thin circuit layers onto the surface of silicon wafers, creating billions of transistors in an area no larger than a fingertip. The battery is an indispensable element for ensuring the iPhone's stable operation. In Shenzhen, China, precision manufacturing chains produce thousands of batteries daily, operating with precision comparable to chip manufacturing. The process begins with thin metal strips, aluminum and copper, coated with lithium cobalt oxide and graphite, then processed in a long furnace with multiple temperature zones in a completely dust-free environment. In the battery pressing phase, sheets already filled with electrolyte solution are placed on a heated platform. The hydraulic press device descends with force calibrated to the Newton, spreading the electrolyte evenly and compressing the electrode layers. Even a small deviation can lead to battery swelling, premature deterioration, or explosion. Before leaving the factory, each battery goes through a hellish trial. Thermal shock chambers cycle the batteries between -20 degrees Celsius and 80 degrees Celsius, followed by dozens of continuous charge-discharge cycles to detect voltage drops, swelling, or internal resistance increases. Only batteries that pass all these rigorous tests are labeled, packaged, and released to market, offering years of safe and stable operation. When all parts are completely prepared, the assembly line reaches its most critical phase, a stage where even the slightest mistake can lead to serious consequences, ranging from defective screens to short circuits, battery malfunction, or explosion hazard. At this point, absolute precision becomes a matter of life. The process begins with the main electronic board containing the CPU and memory being placed into the device case with micron-level precision. The electronic board must be perfectly secured without deviation to ensure flawless connections with other parts. After the board is balanced, the screen is mounted via vacuum suction technology. This technology holds the screen firmly in place and prevents dust infiltration. Immediately after, ultra-thin data cables connecting the screen sensors and circuits are installed by robots, guaranteeing that each electronic connection is stable, safe, and perfectly aligned. Next, the battery, camera module, and vibration motor are installed, extremely sensitive parts. Even a single dust particle infiltrating the camera can create bright spots in images and completely compromise the photography experience. This entire procedure is carried out entirely by robots, from positioning parts and soldering connections to inspecting circuits and final adjustments. These robots operate with precision to the thousandth of a millimeter, ensuring each part is in exactly the right place, minimizing risk and maintaining the highest standards. When the iPhone's physical form is completely finalized, it enters the critical phase that determines whether the product meets the high criteria needed to reach users' palms: quality control. At this stage, technology and human oversight work together to detect every flaw, no matter how tiny. Automated robotic systems perform a series of technical inspections, from touchscreen sensitivity to camera performance, audio output to network connectivity, and processing efficiency. Even a single deviation outside the permitted threshold results in the device being immediately eliminated from the production chain. Additionally, each iPhone must undergo drop tests, where the device is dropped from various heights onto different surfaces to simulate real-world impacts. High-speed sensors and cameras record each impact, verifying whether the screen, frame, and internal parts can withstand impact forces without damage. The devices then undergo water and dust resistance tests according to IP criteria. Each unit is exposed to spraying, immersion, or direct water spray to ensure the enclosure effectively prevents liquids and dust from infiltrating. Only iPhones that successfully pass all these rigorous tests are allowed to advance to the packaging and shipping phase, guaranteeing that the user receives a flawless, durable, and safe product. As the iPhone leaves the factory, the adventure of another essential accessory begins: the phone case. If the iPhone represents cutting-edge technology, the case functions as its silent shield, offering protection against scratches, drops, and everyday wear and tear. The process begins with raw polymer granules, TPU, PC, or silicone. These are meticulously measured and fed into high-precision injection molding devices. These devices heat the raw material to the exact temperature required for perfect flow, then inject it into metal molds that define the precise shape of the case. This initial form then goes through a series of meticulous finishing steps. Trimming removes excess burrs, edges are rounded, and the case is polished to create smooth curves that wrap around the contours of the camera module, buttons, and speaker openings. Each point is shaped to guarantee the case fits the iPhone perfectly, offering both protection and ergonomic comfort. After the physical form is perfected, the case's surface is transformed with UV printing, color coding, or decorative motifs. Each ink layer is applied in a precise mist, then hardened under ultraviolet radiation to create a durable, fade-resistant surface. For transparent cases, an additional anti-yellowing coating is applied that maintains clarity for years of use. From raw aluminum sheets to processors containing billions of transistors, from ultra-thin screens to batteries monitored down to the milliampere, each iPhone goes through hundreds of manufacturing, inspection, and assembly phases with nearly flawless precision. Behind the elegant appearance resting in your palm lies an enormous technological ecosystem of robots, clean rooms, and rigorous criteria operating continuously to manufacture a device that is stable, durable, and meticulously refined at every point. And this is the complete adventure of an iPhone from raw materials to finished product. What iPhone model are you currently using, and what feature do you find most impressive? Leave a comment below to share your thoughts and experiences. And don't forget to like this video, share it with your friends, and subscribe to the channel. This way you'll stay up to date and continue discovering even more fascinating technology stories, behind-the-scenes processes, and cutting-edge innovations in our future videos.